Climate change is happening, and our cities need to adapt quickly.
The battle for climate change will be won or lost in cities.
Cities play an outsized role in climate change, consuming around 75% of the world's energy and producing more than 70% of greenhouse gas emissions. But they can also be part of the solution, creating meaningful impact while being small and nimble enough to avoid the bureaucracy of global politics.
In fact, many have already started work.
2022 marked some of the most extreme weather events on record, with wildfires and droughts ravaging parts of Europe, the US, and Africa, while Asia battled disastrous flooding and monsoon rains. And experts warn it's just the beginning.
What we calculated and what we knew as a 1 in 10 years event is now becoming 1 in 5 years. So the frequency is increasing.
Our cities are at the forefront of those shifts. Today, more than half of the world's population live in urban areas, a figure that's set to rise to 68% by 2050. This migration pattern is driven partly by the climate crisis, which, in turn, creates new risks and stress for urban infrastructures.
Many of our world cities are built on river systems or on water, for example. And as global temperatures rise, we have a lot of sea level rise, a lot of issues related to flooding, and so cities really feel the impacts there.
By the middle of this century, 1.6 billion people living in more than 970 cities look set to face chronic extreme heat as a result of climate change, with average summer temperatures surpassing 95 degrees Fahrenheit. At the same time, 800 million urban residents could be affected by sea level rise, and 650 million by water shortages.
That has major implications, not only for the environment, but also politics, the economy, and society at large.
Urban infrastructure and systems are typically closely interconnected, meaning a failure in any part of the network may be contagious, multiplying the damage.
If London was to flood, then the cost would be immense. London Underground, DLR stations, hospitals, schools, the list goes on.
So what can our cities do to respond to and reduce the rising risks of climate change?
Terry Wills, former director for global initiatives at C40 Cities, a global network of cities aiming to tackle climate change, and now urban strategy leader at design firm Arup, explained more.
There's quite a few cities that have really interesting approaches and initiatives. We always hold up the example of Rotterdam, for example. The Netherlands have reclaimed land from the sea. What Rotterdam is doing is welcoming the water and basically building infrastructure that will take in the water and use the water when it's there, but have different uses for the spaces when the water isn't there. They might have public spaces that when the waters come, you can enjoy the water, you can use boats, but when the water isn't there, it's more of a public realm space for sitting and eating and that kind of thing.
Here in London, the Thames Barrier, one of the largest movable flood barriers in the world, was launched in 1982 to protect the UK capital and its citizens from high tides and storm surges.
The tides that go in and out of London each day aren't a threat to the city. They're contained within the flood defence walls on either side of the river. But if we get a surge element, that allows a hump of water to be formed that can add 1 metre, 2.5 metres on top of the tide, and it's that element that would overtop the defences.
Consisting of 10 steel gates spanning the width of the River Thames, when closed, the barrier can stand as high as a 5-storey building, providing protection to 125 square kilometres, nearly 50 square miles of central London.
The Thames Barrier effectively puts a wall of steel right across the river. We bring the smaller gates into the defence position and then the larger gates before we slow the river down, and then we finally bring the gates up into the full defence position and hydraulically stop the flow of the river.
Hydrological and meteorological data is fed into the barrier's control room every minute from a broad network of tide and river pressure and water gauges. Any decision to close is based on a combination of 3 factors: the height of the tide, the height of the tidal surge, and the river flow entering the tidal Thames.
We've had 206 flood defence closures since 1983. Our busiest flood season was when we had 50 closures in a 3-month period.
Elsewhere, in the equatorial city-state of Singapore, water scarcity concerns over the past several decades have compelled the government to shore up water reserves and reduce their dependence on imports from neighbouring Malaysia.
They designed the water system that maximizes all the possible resources they can get to. So they still import, but much less. They collect all the rainwater into the storages and reuse that water. They collect and treat all the wastewater and recycle quite a large part of that and reuse it. And they also use saline water, so they have the salination plant.
Singapore has also created a fund to combat rising sea levels, with an estimated $100 billion needed in its war chest over the next century to protect the island. Drought and inland flooding are two of 5 major hazards presented by climate change, alongside extreme heat, wildfires, and coastal flooding and storm surges.
In a 2021 report on how cities can adapt to climate change, consultancy firm McKinsey, alongside C40 cities, outlined 15 high-potential actions that cities can take to reduce such risks.
Those include 4 actions all cities can implement to build resilience, such as raising public awareness and boosting financing. The other 11 actions aim to reduce the impacts of specific threats and improve a city's ability to recover from them. Cities at risk from extreme heat, for instance, can apply cool surface treatments like white paint to roofs, walls, and sidewalks to help reflect sunlight and reduce urban heat. Others facing wildfire risks can focus on prevention, such as planting fire-resistant vegetation and creating breaks to slow or control fires. Meanwhile, those vulnerable to coastal flooding and storm surges can invest in flood and storm-resistant buildings and coastal barriers.
In seeking solutions, it's also important to ensure the cure isn't worse than the cause, and that any adaptations don't create more climate risks. That's where nature-based solutions, or so-called blue-green design, can come in.
Blue-green design fundamentally says that we should build with the environment, having new developments which ideally would have the systems that recycle the water, maximize the use of the rainwater, so that's the blue bit, and then the green bit is the systems that have, say, green roofs, lots of green space around the buildings.
Planting trees and installing green roofs and walls, for instance, can reduce temperatures, capture water, and provide sustainable urban drainage solutions.
This is not to say that nature-based solutions can solve everything, but there is much more, I think, opportunities to really combine green infrastructure with green spaces and then have that blue element where we think about maximizing the use of the local resources and recycling it as much as possible.
Still, the threat of climate change is ever evolving. So what more might cities and their citizens start doing now to evaluate and respond to those risks?
They can look at, okay, well, we've put in this much blue and green infrastructure, we've installed, this stormwater management system, but how do you know that those are actually having a result? As a community, have some of the temperatures lowered in a particular area compared to previous years when the temperatures were at a similar level? So understanding the results of those interventions is going to be really important, and Arup wants to provide our cities with kind of the measurement frameworks that they'll need to be able to assess that, which then helps with planning.
Such measures aren't just environmental, they make political and economic sense too. According to the World Bank, investing in more resilient infrastructure globally could save as much as $4.2 trillion in climate change damages.
The cost of installing some of this infrastructure and preparing for the worst might be seen as excessive, but then the damages often felt by extreme flooding, by the heat stress that we're seeing, can often be greater than the cost of the intervention.
The UK's Environment Agency is now exploring how the Thames Barrier might need to be expanded to safeguard the 1.4 million people and £320 billion of property and critical infrastructure it protects.
The Environment Agency has got an adaptive strategy, and that plan, based on data, will react to what's actually happening to sea level rise rather than predictions. And that will offer a range of solutions, but a likely solution for the protection of London is Thames Barrier 2, probably built around 2070, probably downstream of where we are now.
Sustainable Future, brought to you by Petronas.